Good morning, my dear students. I am AGM. Okay. Today we will study the topic called as motion. Motion. So where you will see this is your car, right? So what happens when you sit in the car? Okay. So there are certain trees will be there. Okay. This is what a surrounding it is called. When the car is moving, so this is at a rest. These two trees are rest and the car is moving. Okay. The motion always requires two things. The thing is, one is a reference frame. A reference frame. Suppose I am standing here, I am observing this car. So from the observer point of view, this is what the observer here the car is moving. Okay, these things are at rest, the car is moving according to the observer. This is called as reference frame. This is called as reference frame. So this is how we will tell about motion. So motion needs always the body changes its state with respect to the surrounding is called as a motion of a body. In this, very important things we should study is one is scalar and another is what, my dear student, this is called as vector. The scalar is having magnitude as well as direction. Scalar is having a magnitude, it is having a magnitude only, it is having only magnitude. In vector, it is having magnitude and direction. It is having a magnitude as well as a direction is called as a vector. Scalar is a physical quantity which is having only a magnitude is called as scalar. Okay, vector is the physical quantity. Vector is the physical quantity which is having magnitude as well as direction. Magnitude as well as direction. Okay, this is called as your scalar and a vector. Okay, this is having magnitude as well as direction. So this is the difference between scalar and a vector. See here, first thing, so what is scalar? Scalar, we can give an example of a distance. Give an example of distance, speed and time. So in vector, we can give the examples such as displacement and velocity and acceleration. These are the differences between scalar and vector. Do you understand this concept? No, sir. I'm feeling somewhat difficult. Why you fear? AGM is here. Okay. So, first thing, so we will see with an example of distance and displacement. So, distance and displacement. Distance and displacement. Just now we studied distance is a scalar and displacement is a vector. Distance is a scalar and displacement is a vector. Just we will study with our day-to-day life example. So first thing, one person or a student is going to his school. Okay, this is his home, sweet home. Is moving to his school. Suppose the distance between his house and the school is a 5 kilometer. Is a 5 kilometer. Is going in one direction, right? So distance is of 5 kilometer. And another situation we take that, so this is his house, and this is a school. This is a school. He goes like this and he reaches. This is a 4 kilometer. This is around 3 kilometers. Okay, suppose getting. And after coming to school, he is going to the temple. Okay, he's going to the temple. Okay, he's taking a revolution around a statue that is called as God, right? For example, I'm taking these are the situations are very important in such a way that you will get the clear concept about distance as well as a displacement. Okay, my dear students, let us check out what's going on. Sir, he's going in a straight path. He's going in a straight path. He's moving in a straight path. So here he's going straight and he is taking one turn here. Okay. Then in a third thing, in a temple when he goes, he will revolve around the statue. How many paths? Straight, turning, and another is circular. These are the simple ways to travel a distance. Isn't it? Simple thing it is. Okay. First thing, the distance covered is 5 kilometer. So 5 kilometer is what? Magnitude. Magnitude means what? Magnitude means what? Magnitude means what, beta? It is having only a number. It is having only a number as a 5 kilometer. Sir, here the student is going first towards west and he turns to north. So we know that displacement is going here 4 kilometer and is turning, is taking a 3 kilometer towards this direction. Displacement tells about magnitude as well as direction, isn't it, my dear students? Magnitude and direction. Direction. Okay. So this is what the thing I have written, sir. So I know this one, okay. And in a circular path, every time he is changing the direction. Just check it out. He's changing the direction. At every point, at every second, he's changing the direction. So just check it out. When he moves from his house to school, he covers a 5 kilometer. It is what a distance is 5 kilometer. Is it he is changing here any distance? Suppose this we will take this as a case 1 as he is traveling in a straight path. Okay. So here distance is equals to displacement. Are you writing, sir? Means distance and displacement is 5 kilometer you are telling here. Because the direction is only one. If a body moves in a straight path, distance and displacement will be equal. Sir, he visits to some shop or a bakery further 2 kilometer. Here distance and displacement is also equal, that is of 7 kilometer. Sir, from bakery he comes to his school. He comes to his school, means distance further 2 kilometer is 9 kilometer, but displacement is only 5 kilometers. Displacement is 5 kilometer. Why? So displacement is the shortest path covered in between any two endpoints. So this is what the simple thing, this is what the shortest thing, 5 kilometer only, no. But sir, he went to school, then bakery, then once again this much distance he traveled, no, 9 kilometers totally. But displacement says always a shortest path covered by a body. So displacement is what? Only 5 kilometer, distance is 9 kilometer. Getting, my dear students? Simple it is. So if we come back, this will become minus 2 kilometers. So this is what A to B. Suppose this is house to your school is almost 5 kilometer. We will say displacement is only a 5 kilometer displacement. It indicates that shortest distance between any two endpoints. Okay, my dear students. Then we will go for another case, another scenario. So this is what your house is taking 3 kilometers in one direction. After this, he turns towards his school, towards his school as a 4 kilometer. So total distance is how much, beta? Distance is equals to 3 kilometer plus 4 kilometer is nothing but 3 plus 4, 7 kilometers. Sir, what is displacement? Sir, Jian went to school by this path. Do you know Doraemon is having a bamboo copter? Will take shortest path. Isn't it a right angle triangle? Will take a shortest path. Sir, how much distance he covered? And what is the displacement also? So distance is 3 plus 4. This is what the distance. Displacement means a shortest path. Directly he used to go by bamboo copter, right? So Doraemon is there. We have gadgets, right? I'm also using this gadget. Okay, smart board today. Okay, so suppose I will take this triangle as ABC. So can I apply Pythagoras theorem so that I can get the side of hypotenuse? Isn't it, my dear students? What is Pythagoras theorem? We'll call Pythu Baba. Is that hypotenuse square is equals to sum of squares of remaining sides. S for sides, H for your hypotenuse. Okay. So hypotenuse square I don't know. So this is as AC square as it is. Okay. Okay, so this is nothing but AB square and BC square, isn't it? AC square as it is, AB is 4 kilometers, sir, 4 square. This is what? 3 square. This will be 4 square is 16, 3 square is 9. This is 25, sir. AC square, when it goes this side, square root, this will become 5 units. So this will become 5 kilometer. This is what a shortest distance. This is nothing but displacement is 5 kilometer, distance is 7 kilometer. Are you getting, my dear students? Are you getting? So finally they will reach to their house. Then displacement will become what, beta? Displacement will become 0. The total distance 7 kilometer for Jiang and 7 kilometer for Jiang. That will be 14 kilometers for Jiang distance, and for Nobita distance will be 5 plus 5, 10 kilometers. 5 plus 5 will be 10 kilometer for a Nobita. But displacement both reached the same point, the displacement will become 0. The displacement will become what, beta? Displacement will become 0. Okay, displacement will become 0. Simple. When any object comes to its original position, displacement will be 0, but distance may be positive, negative. Okay, the distance always positive. Okay, and displacement is positive, negative, or 0. Suppose we'll take a circle. Okay, we used to visit a temple. Suppose a devotee takes one full round, circumference of a circle, right? Circumference of a circle. The formula is 2 pi r. So distance is what, beta? Distance is equals to 2 pi r. What about a displacement? What about a displacement, my dear students? This will be 0. He is coming to same position. Okay, if he takes half rotation, then this will be by 2. The answer is pi r. But here, this is the shortest path, right? So displacement will become diameter, right? Displacement will become diameter, right? So displacement will become diameter. This is what our shortest distance. Getting? This is a total in detail explanation of distance and displacement. Now we will come How the distance and displacement? See here, a person is walking from A to B as 5 kilometers. Okay, he comes back to its original position. So here the distance will be 5 plus 5 is 10 kilometers. Okay, and displacement will be what, beta? Displacement. Please tell me, displacement will be what? Zero. No, he comes to its original position. He comes to his original position is 0. And once again he goes to shop here. Once again he goes to shop as a S point. Suppose he goes to 2 kilometers. Then, then, then it will become, so now total distance plus 2, once again this will be what, beta? This will be what? So total it will be of 12 kilometers. Okay, 5 plus 5 plus 5 kilometer going to school, coming to house, and he is going to shop. The total distance is 12 kilometer. What about the displacement? What about the displacement? Sir, he reaches to same point, isn't it? Going 5 is coming back, means this is what? Minus 5. Okay, then once again he is going to negative direction. Plus 5 minus 5 gets cancelled, minus 2, isn't it? So displacement may be positive, negative, or 0. Getting? These are the simple difference between distance and displacement. I hope that you clear with this concept. Please, if you like, please subscribe and share it. AGM द्वारा जनित में जारी नमस्कार.